Hi everyone, this is Fahad Balindong and this is my video tutorial about a certain topic in calculus. Today, I am going to teach you how to find the integral of a function by using integration by parts. But before I'm going to give you an example about this method, so let me first derive the formula of this method. Suppose we have two variables u, v. Okay. So we take the derivative of these two variables. So we have the derivative of u, we have 1 times v du plus the derivative of v. So we copy u times 1. Okay. So this is by product rule of derivatives. So we have duv equals 1 times v, we have v du, plus u times 1, we have u dv. Since our topic is all about integration, so we take the integral for both sides. Okay. So the integral of the derivative of uv is we have uv. Okay. So copy the integral of v du plus integral of u dv. Or we can rewrite this equation as the integral of u dv equals uv minus the integral of v du. Okay. So this is the formula when we use integration by parts. Okay. So like for example, integrate the following. So number 1, we have the integral of x ln x dx. Okay. So solution. So we let u is equal to, we have ln x, and we take the derivative, so we have du equals 1 over x dx. Okay. So for the remaining variables, we have x dx, so we let that as our dv. So x dx. So we take the integral for both sides, so we have dv equals x dx. So we take the integral for both sides. So we have v equals x squared, the integral of x dx is x squared all over 2. Since we have the value for our variables in using integration by parts, so we can now apply integration by parts, this equation. Okay. So thus, so the integral of u dv equals uv minus v du. So we substitute. So we have, for u we have ln x, for dv we have x dx, for u we have ln x, for v we have x squared over 2, minus, for v we have x squared over 2, and for our du, so we have 1 over x dx. Okay, so this is equal to x squared over 2 ln x. Okay, so there is ln x here, minus, so we separate the constants from this expression. Okay, so 1/2, and we also eliminate x. Okay, so we have the integral of x dx. As we can observe in the second term, so we can integrate this. So we have x squared all over 2 ln x minus 1/2 So the integrate of x dx, we have x squared all over 2 plus c. And this is equal to x squared all over 2 ln x minus, okay, so 1/2 times x squared over 2, so we have x squared all over 4. So 2 times 2, 4, plus c. Or we can factor it as 1/2. So we have x squared times, we have ln x minus 1/2, okay, plus c. So this is now the integral of ln x, okay, x dx. Okay. Anyway, x dx. So let's have another example. Okay. So we have the integral of x squared e to the x dx. We have the solution. Okay. So we let u equals to, we have x squared. And we take the derivative, we have du equals 2x dx. Okay, so and for the remaining variable e to the x dx, we let us dv is equal to e to the x dx. So we take the integral for both sides. Okay, so we have the integral of dv equals the integral of e to the x. So the integral of dv is, we have v equals to e to the x. So the integral of e to the x is e to the x. Now we can use the formula. So we have the integral of u dv equals uv minus the integral of v du. Okay. So our u is, we have x squared, our dv is e to the x dx equals x squared, our v is e to the x minus e to the x, and our du is, we have 2x dx, and this is equal to x squared e to the x minus, okay, we can separate the constant. Okay, so we have 2 the integral of x e to the x dx. So as we can observe in the second term, okay, so we have a symbol of integral. So we are going to integrate this. And we can only use integration by parts, because if we are going to use integration by substitution, so this might lead us into problem. So this is equal to x squared e to the x minus 2. This time we are going to use u sub 1, v sub 1 minus the integral of v sub 1, and we have du sub 1. Okay, so we'll let u sub 1 equals to x, okay, our x. So the derivatives of u sub 1 is equal to dx. For the remaining variable e to the x dx, we let it as, we have dv sub 1 is equal to e to the x dx. Okay, so we take the integral for both sides. So the integral of dv sub 1 is, we have v sub 1, and the integral of e to the x dx is, we have e to the x. So continue. Okay, so we have here x squared e to the x minus 2 times our u sub 1 is x, okay, our v sub 1 is e to the x minus the integral of v sub 1 e to the x, and we have the du sub 1, we have dx. Okay. So we distribute, okay, x squared e to the x, we have negative 2x e to the x. So negative 2 times negative, so you have positive 2. We have the integral of e to the x dx. Okay, so there is an integral sign here, so we integrate this third term. So we have x squared e to the x minus 2x e to the x plus 2. So the integral of e to the x is we have e to the x. So plus c. Okay, so this time we can factor out e to the x. So we have e to the x times x squared and then negative 2x plus 2. Okay, so plus c. So this is now the integral of x squared e to the x dx. Okay, so this is our answer. For your exercises, you may answer this problem. So integrate the following. Number 1, we have the integral of the square root of x, ln x dx. Number 2, we have the integral of x squared cosine 2x dx. For number 3, we have the integral of e to the x sine 2x dx.